How do you build a swimming pool that's 60 meters deep, holding 14 million liters of water? This isn't just about digging a big hole. This is about building a massive pressure vessel designed for extreme depths, constant stress, and human safety. This is the story of how engineers built Deep Dive Dubai. The project started with a clear, ambitious goal: create a world-class facility for professional freediving, scuba training, filmmaking, and research. Depth was the key feature, and safety had to be beyond anything seen in a commercial diving facility. So, the engineers threw out the rulebook for building swimming pools. They decided to treat it like a submerged building. Let's talk about pressure. At 60 meters deep, the water pressure is a crushing 7 times greater than the air we breathe. Every square inch at the bottom of the pool is under constant, immense force. Standard pool construction would buckle instantly. So, the team designed the pool as a reinforced concrete shell, much like you'd find in underground tunnels or bunkers. They developed a special high-strength concrete mix, engineered to resist cracking under the relentless hydrostatic load. The steel rebar inside the concrete wasn't uniform either. It was packed much more densely near the base, where the stress is most intense. The shell walls even vary in thickness, concentrating strength exactly where it's needed most, and saving material where the load is lower. It's an incredibly efficient and robust design. But building a strong shell is only half the battle. Dubai's ground conditions, with sand and shifting layers, presented another huge challenge. A 14 million liter pool is unbelievably heavy. To prevent it from sinking or shifting, engineers stabilized the entire site with deep foundations. The pool itself essentially floats inside a larger, reinforced basin that controls any settlement and distributes the massive weight evenly into the ground. Now, what about keeping all that water in? A leak at 60 meters deep wouldn't just be a maintenance headache. It would be a potential structural disaster. Absolute reliability was non-negotiable. The solution was a multi-layered waterproofing system. This included flexible membrane barriers, special crystalline additives mixed directly into the concrete that seal pores from within, and external sealing systems. Each layer works independently, creating a fortress of redundancy. If one layer were somehow compromised, the others would hold, preventing a catastrophic failure. Then there's the temperature. Divers need stable, warm water to operate safely and comfortably. The pool is kept at a balmy 30 degrees Celsius. For a volume this enormous, that's a serious engineering feat. Heat loss and gain are constant battles. The facility uses an industrial-scale heating and cooling system, fully integrated into the water circulation network. An array of sensors constantly monitors the water temperature at different depths, preventing cold, stratified layers from forming, which could be dangerous for divers. And clarity? You can't film or train if you can't see. 14 million liters of water have to be kept crystal clear. The entire volume of the pool is circulated and filtered every 6 hours. The pumps and filters here are not what you'd find at a hotel. They're municipal-scale systems. The filtration process itself is multi-stage. First, mechanical filters remove particles. Then, biological treatment deals with microorganisms. Finally, powerful ultraviolet sterilization neutralizes any remaining pathogens, all while keeping chlorine levels low to protect divers' eyes and their expensive equipment. Visibility at 60 meters is 0 in natural light. Water absorbs light incredibly quickly. So, engineers embedded a custom lighting system directly into the pool's walls. These fixtures are pressure-rated to withstand the immense force and specially sealed to prevent corrosion. The lighting is divided into zones that can be controlled independently, allowing staff to simulate different underwater environments or highlight specific areas for training and filming. Of course, putting electricity underwater is risky business. To ensure safety, all the lighting and equipment operate on low voltage. The main power supplies are isolated far from the pool structure itself. On top of that, redundant grounding and fault detection systems are always on watch, ready to shut down a circuit instantly if any anomaly is detected. Safety is paramount. The inside of the pool isn't just an empty chamber either. It's an underwater cityscape, a breathtaking sunken world complete with furnished rooms, stairwells, and open plazas for divers to explore. Every single one of these submerged structures had to be meticulously analyzed. If air gets trapped, it creates a powerful upward force, or buoyancy. Engineers had to calculate this precisely, adding hidden ballast and special vents to each structure to ensure they stay firmly in place and don't become underwater hazards. The materials used had to be chosen with extreme care. Standard steel would rust and fail in no time. Instead, the team selected marine-grade alloys, specially treated concrete, and advanced polymers designed for long-term submersion. Even every single nut and bolt was chosen for its ability to resist corrosion. But the most impressive engineering might be the safety systems you don't see. A network of cameras and sensors covers every inch of the pool. In a central control room, operators monitor every diver in real time. They can track their location, depth, and even their behavior. If a diver shows any sign of distress or stops moving, the team can intervene immediately. What happens if a diver has an equipment problem at depth? Ascending 60 meters to the surface isn't always a safe option. That's why the pool is equipped with a network of emergency breathing systems. These are hard-plumbed directly into the structure, allowing divers to access a backup air supply at various points without needing to make a dangerous emergency ascent. These systems were tested under pressures far beyond anything they'd experience in normal operation. The very shape of the pool was designed around emergency extraction, with platforms and access points at multiple depths to allow for staged recovery and in-water decompression if needed. The construction process itself was a masterclass in precision. The concrete shell was poured in carefully planned stages to manage the stress as it cured. The temperature and humidity inside the construction site were tightly controlled to prevent tiny microcracks from forming in the concrete. Strain gauges were embedded directly into the structure, allowing engineers to monitor the pool's behavior in real time as it was built. Once the structure was complete, the commissioning phase began. The team didn't just turn on the taps. They filled the pool slowly, incrementally, stopping at various depths to inspect every surface for leaks, measure deformation, and test every single system under real-world load. This painstaking process allowed them to validate all their design models and ensure the structure was behaving exactly as predicted. This project was a massive collaboration. Structural, mechanical, and electrical engineers worked hand-in-hand with experts in diving medicine, materials science, and life safety. Every decision had a ripple effect. A change to the filtration system could impact the electrical load, which could then impact the structural design. Everything was interconnected. The result is so much more than just the world's deepest pool. It's a completely controlled underwater environment, engineered to be predictable and safe under the most extreme conditions. Any engineer can design for depth, but true engineering is about creating control. Deep Dive Dubai transforms a hostile, high-pressure environment into a usable, safe, and awe-inspiring space. It's a testament to how civil engineering principles can be scaled beyond their conventional boundaries. This single structure combines the design theories of tunnels, pressure vessels, and life support systems, all within what looks like a recreational facility. When you look at Deep Dive Dubai, you shouldn't see a pool. You should see a machine that constantly processes load, heat, chemistry, and human risk. It's a stunning example of systems engineering, where every single component works in harmony to remove uncertainty, and that is how engineers built the impossible. Thanks for watching. If you found this dive into engineering fascinating, be sure to like this video and subscribe for more deep dives into incredible structures. See you next time.